All right, so in this unit, we're going to be taking a look at quadratic equations, quadratic relations, and combining the last two units and kind of applying them into some more complex situations. So we're going to start looking at the vertex and how we can convert to vertex form from standard form. So something that's important to remember is the concept of perfect square trinomials. Perfect square trinomials, recall, are the situation where we have something plus something or something minus something in the brackets, and we square that. And so we'd have a plus b times a plus b. And when you FOIL that out, what you get is a squared and then the b squared on either end. And then in the middle, it's 2 times the a value and the b value. If it's positive, there's a plus sign there. If it's negative, there's a minus sign there. So they're fairly straightforward to calculate each time, and also factor when you recognize that this just factors down to this. And this is going to help us out when we look at how to convert from the standard form to the vertex form by completing the square. So just a couple quick examples. If I have x plus 4 squared, then you would get x squared plus 4x plus 16 when you FOIL it out, and that 4x plus 4x, that's that 2 times ab. So there's our a value squared, there's our b value squared, and then there is 2 times 4 times x right there. Same thing on the next one, x squared, negative 3 squared, and then 2 times negative 3 times x would be negative 6x. And again, we can take that backwards and just look at this situation where this here is 2 times the square root of that. So moving on, we're going to take a look at completing the square. So this method here is very procedural, and if you take the time, follow along with it, it becomes fairly easy, but it's just a matter of paying attention to the order in which we do each of the steps. So first, expanding using some FOIL in there allows us to go from vertex form to standard form. So we've done something like this before in our previous units. We could take an equation like this, which is vertex form. Recall, this is our A, this is our H, this is our K. So we have a parabola that would be opening upwards and is stretched out, so it gets narrower. And the vertex would be at positive 2, positive 6. So from here, we can convert this to standard form by expanding out the x plus 2 squared, or x minus 2 squared, sorry. So if we do that, we get 3, and then that would be x minus 2 times x times another 2 would be negative 4x, and then positive 2, negative 2 squared would be positive 4. So that times 3 plus 6. And then we just multiply that 3 through, and we get, that's x squared. 3 times x squared minus 12x, and then 3 times 4 plus 12 plus 6. And so we get y equals 3x squared minus 12x plus 18. So there we have a equation in standard form, and then from the equation in vertex form. So that's easy. We've done this before, but we want to be able to go backwards from standard form to vertex form. So we're going to need to be able to break this up. And if you notice, along the way, we have this perfect square trinomial. And so that's what we're going to create. We're going to create a perfect square trinomial along the way to solve this. So if we go about taking these two questions, so we got one changing 2x squared plus 16x plus 5 to vertex form, and then we're going to find the vertex of negative 3x squared plus 12x minus 11. So let's do part A first. So in A, we have y equals 2x squared plus 16x plus 5. Now the first step all the time is to factor out the a value from the first 2 terms. Just the first 2 terms, not from every term. So just from the first 2 terms. So we're going to factor out a. We're going to get y equals 2 bracket x squared. So whatever the a value is, we take it out. So we always want to have an x squared here. Every time we're going to have just an x squared. And then we're dividing 16 by 2 as well. That's going to give us plus 8x. Close the bracket, and then we leave the plus 5 at the end. So we're going to kind of ignore the plus 5 for now. We're just going to deal with that at the end. So this is all we're worried about now, is what's in the brackets. We've gotten rid of the 2 from the first pair, and now we're just worried about what's in the brackets. Now, we want to convert this to a perfect square trinomial. So from before, this is the a, the x, times 2 times the b. So we've doubled that, so we take half of that and square it. So y equals 2x squared plus 8x. Half of 8 is 4, and we're going to square it. So that's what we do each time. We take half of 8 and we square it. So we're going to add that. So we're going to add 16. Half of 8 squared is 16. We're going to subtract 16 as well. Why? Because we can't just randomly add 16. So by adding 16 and subtracting 16, we're essentially adding 0. So here we are. We have a perfect square trinomial. It's actually from the very first example where we had x plus 4 squared. So we've made a perfect square trinomial right here. These three terms create a perfect square trinomial. We did that again by dividing 8 by 2 and squaring it. So now we need to get rid of this minus 16. We can do that by doing a partial expansion. So normally we would take that 2 and multiply everything inside the brackets by 2. We're only going to multiply the negative 16 by 2. So we're going to have 2 bracket x squared plus 8x plus 16. And then we're going to close the bracket. There's our perfect square trinomial. Now we're going to multiply negative 16 by 2. That's what's removing it from the brackets. So we get negative 32 plus 5. And now we can finalize this. This is a perfect square trinomial. We know that because that's what we made, specifically made a perfect square trinomial. That value there is going to be, the b value is going to be 4. So plus 4 squared, and then negative 32 plus 5 is going to give us negative 27. So there we've changed this equation up here in standard form to vertex form. Notice the a value is still the same, but now we have a vertex form, and the vertex here would be negative 4 and negative 27. Let's try that again. Same process. If you would like, write out the process as a series of steps for yourself. That would be beneficial for your culminating task as well. In the next case, we're going to follow this same process. Divide out the a, turn this into a perfect square trinomial by adding and subtracting the same value, expand out the last value, and then convert to a perfect square and simplify. So in this case, we have y equals negative 3x squared plus 12x minus 11. So again, we're going to factor out the a value of negative 3. That means we're left with x squared, and then positive 12 divided by negative 3 is going to be negative 4x. Again, we're just factoring it out of the first 2 terms. The c value stays as it is. Now, negative 4 here, that we take that, we divide it by 2 and square it. So that's going to be 2 squared, or specifically negative 2 squared. So negative 2 squared is going to give us 4. So we're going to add and subtract 4. Negative 3 x squared minus 4x plus 4x minus 4x. It's always plus minus. Always in the order of add the value we want and then subtract, because perfect square trinomials always have an added c value. Close the bracket, minus 11. Now, let's get rid of the negative 4 at the end here by multiplying through. Y equals negative 3, x squared minus 4x plus 4. And then negative 3 times negative 4 is going to be positive 12 minus 11. This is a perfect square trinomial. We know that because we made it. And this is very similar to the x minus 2 portion of the example that we did earlier. So we have 3x minus 2 squared. And then positive 12 minus 11 is going to be positive 1. And there we have the equation in vertex form. We want to know the vertex. So therefore, the vertex is 2 and 1. So each time, what you're doing, you're factoring out the a value, the entire a value from the first two terms. Then you're creating a perfect square trinomial. It's half of the term right here squared. So half of it squared. You add and subtract that. Always add and subtract in that order. Multiply out the last number. So the a value times the last number, the subtracted number that we added. We have a perfect square trinomial. So we just write that as a perfect square. And then we simplify the last piece. It's the same steps every time. Now, during this unit, you're going to get some questions that will discuss creating equations for price change versus like sales. So as we change the price of something, the amount of money made will change, or the amount of items sold will change as the price changes. So a couple concepts to go over. First, the term revenue. Whenever you hear the term revenue, that is the amount of money being made. So that's how much money you're taking in. In our cases that we're going to be working with, revenue will be the price of the item times the number of items sold. So if I was selling ice cream for $2 a cone and I sold 10 cones, $2 times 10, my revenue would be $20. In our situations, we're going to be working with problems where the price will change based on, or the number of items sold will change based on the change in price. So we're going to have our revenue formula as the original price plus or minus the price change times X. And that in one set of brackets, and then the original number of sales plus or minus the change in sales times X. So OP, original price, CP, change in price, OS, original sales, CS, change in sales. And then X is the number of changes and will be the variable in our equation. So let's take a look at that and apply that in a situation here. So we have, pull this back a bit. The price of a ticket at a theater is $20. The theater typically sells 500 tickets at this price. A survey found that for each $1 increase in price, 10 fewer tickets are sold. So for every dollar we go up, we would sell 10 less tickets. So what is the number of $1 increases that will maximize revenue? What is the price per ticket that will maximize revenue? And what is the maximum revenue? Well, let's create an equation and then we'll know a little bit about modeling this situation. So the revenue is equal to the original price of $20. And in this case, we're increasing the price by $1 plus 1 times X. X is the number of $1 increases. Multiply that by the original sales, which were 500. And then it's 10 fewer tickets sold. So 10 would be subtracted from 500. And again, we're multiplying that by X. Each change in X, so every time we go up by 1, this goes down by 10. So there's our equation. Now that's a quadratic equation. That is in zeros form, the A value is positive, so we know we're going to have some sort of graph looking like this. We're not sure where the axes in that are, but it's going to look like this. Meaning that the revenue, which is going to be on the y-axis, say the graph looked like this. This will be the revenue. The revenue is going to maximize at the vertex. So we need to find the vertex of this graph. So there's a couple ways of doing that. We can try the zeros method, but we haven't learned how to do that yet with a value in front of the x. So let's use the completing the square method. That means we need to change this to standard form by foiling this out. So we're going to FOIL this out. We have 20 times 500, which is going to be 10,000. And then 20 times negative 10, which is going to be negative 200x. 1x times 500, which is going to be plus 500x. And 1x times negative 10x, which is going to be negative 10x squared. So here we go. We'll simplify that middle term. 10,000 plus 300x minus 10x squared. There's our equation in standard form. And just to help out, we're going to rewrite it in descending order. Negative 10x squared plus 300x plus 10,000. Now, let's simplify or complete the square here. So we're going to divide out the A value. Negative 10 gets divided out of the first two terms. So that's going to give me negative 30x plus 10,000. Now, half of this squared. So half of negative 30 is negative 15, and we're going to square that. And 15 times 15 is 225. Add and subtract 225. And then add. Now that we have our perfect square trinomial, we can get rid of the negative 225 in the brackets. So we're going to do that by multiplying it by the negative 10. And that's going to give us a positive 2,250 plus 10,000. And now we'll finish this off. We've got a perfect square trinomial here. So that's going to give us negative 10x. And then it was minus 15 squared. And then this will give us plus 12,250. So here we have our equation in vertex form. And we can find the number of $1 price increases that will maximize revenue. So if we take a look at the graph, I'm going to quickly sketch a little graph here. We have a vertex at 15 and 12,250. So say right here. And this is 15. We're using X and R. And it's opening down. We're not sure where it's crossing the axes and that. But up here at our vertex at 15 is our X. How many $1 increases? 15 $1. Sorry, there we go. On screen now. 15 $1 increases, because that's on our X. That's our X value. Will produce that revenue. So for A, 15 $1 increases. Will maximize revenue. And then the second question, it said, what is the price per ticket that will maximize revenue? Well, this here is the price per ticket, 20 plus 1 times x. So for B, we have 20 plus 1 times 15, which is equal to $35. So $35 is the price that will maximize revenue. It will make the most money at $35. And what is the maximum revenue? Well, the maximum revenue is the solution to this whole equation here, with x being 15. So we have revenue equal 20 plus 1 times 15 times 500 minus 10 times 15. And if we simplify that, again, that was 35 times 10 times 15 is 150. 500 minus 150 is going to give us 350. And then when we multiply those out, we're going to get 12,250. Now, notice that is the y value of the vertex, because that is the maximum value. So you could just say that's the maximum revenue, because that's what the vertex represents in this situation.